Welcome to PreCalc Lesson 2-3, Day 1. Notes on synthetic and long division. When we are dividing, we really have a divisor and a quotient and a remainder and a dividend. The dividend is the item or the expression that we are dividing. The divisor is what we are dividing by. The quotient is the other factor. Divisor times the quotient. If they are factors of the dividend, we'll multiply to exactly the dividend. Sometimes they don't multiply to exactly the dividend, so we have to multiply the divisor and the quotient and add the remainder to get the dividend. Factors are numbers you can multiply together to get another number. When dividing, factors have a remainder or zero. Both polynomials must be in standard form in order to divide. That's really important. Always make sure you put it in standard form first. Exponents go from highest to lowest. Using zeros as placeholders for any missing items in the dividend. So, in this one, let's say I did not have an x term, I just had x squared plus, or x squared minus 4, I would put a 0x in the dividend. Use zero placeholders for any missing terms in the dividend. Example 1. Factor completely using long division as if it is a factor. Factor completely using long division if it is a factor. So let's see if this is a factor by doing long division into this polynomial. So our divisor is 2x minus 5. Our dividend is 6x cubed plus 17x squared minus 104x plus 60. When we do this, we look at the first terms. 2x times what is 6x cubed? Sometimes people do 6x cubed divided by 2x is what? Well, you're going to need to multiply by 3x squared. So the way I view it, 3x squared times 2x is 6x cubed. Some people do 6x cubed divided by 2x is 3x squared. Gives you the same number. Once you have that first part of the quotient, you have to distribute it to both terms in your divisor and write those down here. 6x cubed minus 15x squared. Now normally we just subtract these, but when we're subtracting polynomials, we don't want to subtract, we want to change all the signs and combine like terms. So at this point I will change the signs in every term I just created by doing the product of this part of the quotient and the divisor, and now I'll combine like terms vertically. The 6x cubes go away, we now have 2x squared, and we can bring down the rest of the polynomial expression so we don't forget any terms up there. Now I'm focused on the 2x cubed and the 2x. 2x times what? Sorry, is 2x squared, not cubed. 2x times 2. So 2 times, or actually I need another x. 2x, actually not even 2x. Oh my gosh. I'm sorry, just x. X times 2x is 2x squared. I have to distribute it to both parts of the divisor, so x times negative 5 is negative 5x. Instead of subtracting, we change the sign on all of these new ones that we generated, and we combine like terms. That cancels. This gives us negative 99. Bring down the other term. 2x times what is 99x? Well, I don't need an x, but I need something that multiplied by 2 would be 99. That's 49 and a half. I don't really like that. I'm going to leave it as a fractional form. I'll say 99 halves. So we'll do plus 99 halves. That gives me 99x. Oh, and it needs to be negative. It needs to be negative because I want it to be the same number. So negative 99x. Negative 99 halves times negative 5 is positive 247.5. Key step to remember, change the signs on everything that we just generated. and combine like terms. 60 minus 247.5 as a fraction is negative 375 halves. So we have that as our remainder, plus negative 375 halves over the divisor 2x minus 5. There's our factor. It doesn't have any fractional exponents. It is a polynomial function, but this is a lead coefficient that is a fractional value. The next one, factoring completed. So by the way, is it a factor? Determine if it's a factor. It's not a factor because there is a remainder. I'm going to go through the steps of long division for this next one and then determine if it is a factor. So we have our divisor 3x minus 4 going into our dividend 6x cubed plus x squared minus 117x plus 140. There are no missing terms, so I didn't have to plug in a 0 anywhere. Focusing on the 6x cubed, I have to multiply by 2x squared, so 2x squared times 3x gives me 6x cubed. 2x squared times negative 4 gives me negative 8x squared. Change the sign on every term. And we have those cancel. We have 9x squared. Bring down the rest of the expression. To multiply to 9x squared, 3x would have to be multiplied by 3x, positive 3x, giving us 9x squared minus 12x. Change the sign on the terms we just generated. Combine like terms. The first ones go away. Now we have negative 117 and 12 is negative 115x. Bring down the 140. To multiply to 115, I need to multiply the 3x by 115 thirds. So I'm guessing it's not a factor. Let's take a look. Going to multiply that by there, we have, that's going to give us positive 115x. 115 thirds times negative 4 is negative 460 thirds. But we have to change the signs. Don't forget that step. And then I'm going to combine that with the 140. That's a 140, not a 146. Leaving me with the remainder of 880 thirds. Because we have a remainder, and that 880 thirds goes over the divisor of 3x minus 4. Because we have a remainder, this is not a factor of the dividend. Let's take a look at a couple of other examples. But first, polynomial division. Let f of x and d of x be polynomials such that the degree is less or equal to the degree of the other one, and they're not degree of 0. Then there exist unique polynomials, q of x and r of x, such that f divided by d equals your quotient plus remainder over the divisor. Or this is equal to your divisor times your quotient plus the remainder. We already have the same thing listed on the other side of the page. I'm going to give you some examples of ones that actually are factors because they have a non-zero remainder. So let's take a look at this one. We have 2x minus 1 going into 6x cubed minus 5x squared plus 9x plus 6. It's in standard form. There are no missing terms that I have to fill in a 0. To get 6x cubed, I'd have to multiply by 3x squared. So that gives me 6x cubed minus 3x squared. Change the signs on the terms we just generated. Combine like terms. Wait, that's not negative 8 because that's a positive 3. Negative 2x squared plus 9x plus 6. This will multiply if I do negative 2x. Negative 2x times that. Oh, not negative 2. Why am I doing that? Just opposite of x. Negative x times 2x is negative 2x squared plus x, negative x times positive 1. Change the signs on every term I just generated. This becomes 8x plus 6. Now I say what will multiply to 8x? 2 times 4, so 2x times 4 gives me 8x. 4 times negative 1 is negative 4. I'm going to change the signs on those terms that I just generated. This gives me 10, which does have a remainder. So let me just double check to make sure everything's right here, that I didn't make any mistakes. We did this correctly. It says to have a non-zero remainder, and 10 is a non-zero remainder. So we have plus 10 over the divisor. That's what this is saying and what that's saying on the front page. Your quotient plus the remainder over the divisor, 10 over 2x minus 1. So 2x minus 1 is not a factor of this polynomial function. It does not go into it evenly. There is a remainder. One more example of this before we get to division when the degree is higher, or when degree is 2 or higher. Right now we only have a degree of 1 on our divisor. So we have x plus 1 going into our divisor of 4x to the 4th minus 2x cubed. And right now I see that I'm missing something because as I'm writing it out, I'm paying attention. We're missing an x squared term. So I have to put it in as 0x squared plus 8x minus 10. Again, look at the first term, 4x to the 4th, so I need 4x cubed. When I multiply that by x, I get 4x to the 4th. By 1, I get 4x cubed. Change the sign on both terms, combine like terms, and copy down the rest of the polynomial function of the divisor, or the dividend. Negative 6x cubed, x times negative 6x squared would give us negative 6x cubed, which is what we want. Negative 6x squared times 1 is negative 6x squared. Change the signs on the terms we just generated and combine. We now have 6x squared plus 8x minus 10. X times 6x would give us the 6x squared. 6x times 1 gives us 6x. Change the signs and combine like terms. We have 2x minus 10. X plus 1 does not go into that evenly, unfortunately, but x times 2x, or x times 2 is 2x. 2x times 1 is 2. Change the signs. We get negative 12 as our remainder. So we have this as our quotient plus negative 12, or you could just write minus 12, over the divisor of x plus 1. So we have our quotient plus the remainder over the divisor when it does not go in evenly. One more example for this video clip on long division, and then a separate video clip on synthetic division. This divisor right here, so here's our divisor, here's what we're dividing our dividend, here's our divisor. The degree on the dividend is higher than the degree on the divisor. There are no terms missing from the dividend. There are no terms missing from our divisor. You're going to follow the same process with this for long division, and unfortunately you can't use synthetic division when we have a degree of 2 or higher. You have to use long division for polynomials. Looking at x cubed, to be multiplied by x, for x squared would give us x cubed. X times negative 5x is negative 5x squared. X times 6 is positive 6x. Go through and change the sign on all three terms that were just generated, and then combine like terms. This gives me 4x squared minus 20x plus 4. I do this as long as I can until I can't get it to go in anymore. This is 4x squared. X squared times 4 will multiply to 4x squared. So when I do that, I get 4x squared minus 20x 4 times 6 is 24. So plus 24. Change the sign on every term we just generated. Combine like terms. We are left with a remainder of negative 20. So this quadratic did not go evenly into this cubic because we have a remainder of negative 20, and we put that over our divisor of x squared minus 5x plus 6. This is our answer to this problem right here. Quotient of x plus 4 plus the remainder of negative 20 over the divisor. Last example for long division with a degree higher than 1, a degree of 2 or higher. I have 2x to the 4th plus 9x cubed. I have to be careful this does not have an x squared term. Minus x plus 26. That is our dividend. Our divisor is x squared plus 6x plus 9. 2x to the 4th, I need to multiply x squared by 2x squared to get 2x to the 4th. 2x squared times 6x is 12x cubed. 2x squared times 9 is 18x squared. I'm going to change the sign on all of these. That was a 12, yeah. And combine like terms. So this gives me negative 3x cubed. Negative 18x squared, bring down the negative x and the positive 26. Multiplying to negative 3x cubed, we need to multiply by negative 3x. This gives us the negative 3x cubed. We want that to match for now. Negative 3x times positive 6x is negative 18x squared. Negative 3x times 9 is negative 27x. When we change the signs and combine like terms, we're left with, oh, I need to combine those ones, 26x plus 26. X squared cannot multiply by anything to become 26x. So this becomes our remainder right here of 26x plus 26 all over x squared plus 6x plus 9. We have our quotient plus our remainder over our divisor. This concludes the video clip for long division. We'll be looking at synthetic division in just a minute on the other clip.